Hey there, hope you're well. This video is for you if you're looking for some site reliability questions that you might have in a test, for a screening for a job, or even actually in the interview itself. This is a way for you to challenge yourself ahead of time to see if you know enough about SRE. Maybe you're going for an SRE role. Maybe they've asked you in the job description for a cloud DevOps role. Do you know about SRE practices? You'll be expected to know this. So these are similar, as I say, to a screening test or interview questions. Join me as we read and answer these questions, and I will share my thoughts and my reasoning behind my answers. We'll read together the correct answer and the explanations for those. If you want to play along, you can pause right after I ask the question and unpause when I'm about to give you the answer, or just watch in real time. These questions were created with the help of AI. Also, they are not copyrighted materials. Also, they're not always perfectly phrased, so it's kind of like real life, like a human would do, and it's not always going to be the case that you get a fair question that's been asked in the proper way. So we'll see if that happens or not. Let's get started. So question 1, which of the following best describes the concept of error budgets in SRE? A method to allocate server resources based on traffic. A quantitative measure of the acceptable level of downtime for a service. Financial framework for managing infrastructure costs, or a tool for monitoring user engagement metrics. Right. Now, I don't remember for sure, but I do have quite a fair idea. I do think that I think it's B, an acceptable level of downtime. It is a budget for error, just like you have a budget. A monetary budget is the amount that you're willing to spend, and you won't tolerate more than that. A budget is to say, we accept there are always going to be errors in what we do, and we have a maximum allowable error, and if we go over that, then we know that we need to do something. But we know it's not a perfect world. We will always have errors. So I think it's B, a quantitative measure of the acceptable level of downtime. The other ones just don't make any sense to me. So let's have a look at the answer. And indeed, answer is B. Error budgets quantify acceptable level of downtime for a service, balancing reliability and feature development. They help teams to prioritize reliability while allowing for innovation. Okay, yeah, I get that, and I think what they're saying is that when you innovate at the bleeding edge, right, then potentially you can innovate really, really faster if you're willing to accept that you're going to make a lot of errors along the way, and that's okay to some degree. But at some point, you're going to say, well, we need to set a budget. We're going to allow errors, but for our company, this is acceptable for us. And for other companies, they may be that they have a larger error budget. So it really depends. Question 2, in SRE, what is the primary purpose of service level indicators, SLIs? Is it to track user complaints and feedback, to provide a measure of performance against a defined reliability target, to estimate the cost of downtime, to generate automated reports for service usage? So, by the way, I don't know about you, but most people who are not going for an SRE job don't really know SRE very well, and I include myself there. So this is more of a learning experience for me. I don't expect to absolutely ace this test. I know that in SRE there are SLAs, SLOs, and SLIs. SLA, service level agreements, everybody has known about that for years and years, for decades in fact. SLIs and SLOs are newer but related. SLI stands for indicators, SLO stands for objectives. So, and SLOs and SLIs are closely related. Now, I'm not sure what this is. It's not automated reports, and it's not tracking user complaints and feedback. It's going to be B or C. Measure performance against a defined target, or estimate the cost of downtime. It's not cost. I think it's B. I think the indicator is the measure, and I think the objective, the SLO, is actually the target service level objective. So I think the SLI is actual outcome against the SLO, which was desired outcome, against the SLA, which is kind of like it's more of an agreement with your stakeholders. So I'm pretty damn sure that it's B. It better be. It better be. Yes, it is. SLIs measure performance against reliability targets. So actual performance against the target, helping teams gauge how well a service meets the expectations set by service level objectives, SLOs. Isn't that what I just said? Great, fantastic. Question 3. Which of the following practices is not a fundamental principle of chaos engineering, not part of chaos engineering? Injecting failures into a system to test its resilience, running experiments in production environments, assuming that all components are reliable, observing system behavior during controlled failures. Okay. Yeah, interesting. Okay, it's definitely not A, injecting failures to test its resilience, because I know that is part of chaos engineering. Also, running experiments in prod is part of chaos engineering. Now, D, observing system behavior during controlled failures. That's got to be part of chaos engineering. I mean, the whole point is the failure is created by you. It's controlled. I guess it's not a completely crazy failure. It is preferably a controlled one that you can easily fix if you need to. It's got to be C, assuming that all components are reliable. Okay, that kind of makes sense, that you're going to assume that you're going to break something. But I did wonder if maybe that could still be true. Like maybe it's just an assumption you make as part of the analysis. But it's got to be C. That the whole principle, part of the principle of chaos engineering is you go in there expecting that what you do is going to break the system. That's what they're saying about C. So let's have a look. Explanation. Chaos engineering operate, indeed, it's C, on the assumption that components can fail. You expect to fail, highlighting the need to test resilience instead of assuming reliability. So I think the point here is that you know that no system in the world, no matter who has made it, will ever have a 100% reliable system. Or anything can fail. I think that is the point of what they're saying here. The chaos engineering has the assumption that anything is fallible. Okay, great. Now question 4. What is the main function of a runbook in SRE? A guide for deployment processes, a detailed document outlining service architecture, a collection of troubleshooting procedures for incidents, a budget estimate for operational costs. Okay, so I know for a fact that a runbook is a process. It's something I've used for years, even before SRE was a thing, even before DevOps was a thing. So it's a process. So it's not going to be a detailed document outlining service architecture. That can have several different names. It's not a budget estimate. It's going to be a guide for deploying or troubleshooting procedures. And for me, it's C. It's an incident procedure. Kind of like even on airplanes, if there's a really major problem, pilot will run through a checklist, same kind of thing. I've never heard of it being a guide for deploying. I sure hope that's not the right answer, because I mean maybe it could be as well, but it's definitely C. It's got to be C. Let's have a look. So answer is C. Runbooks contain troubleshooting procedures for incidents, providing step-by-step guidance to SREs during operational challenges. Indeed. Question 5. Which algorithm is commonly used for load balancing in distributed systems to ensure even distribution of requests? Is it A, Dijkstra's algorithm, B, round robin, C, depth first search, D, A-star search algorithm? So some of these, well, two of them, I mean, I've actually heard of most of these, but the last two, so we're trying to get load balancing and to have even distribution of requests. So we don't want to overload one backend compared to another. We want an even distribution. So it definitely has nothing to do with search algorithms. And I don't know what this Dijkstra's algorithm is. I've heard of it. I think it's just round robin. It's very simple. I think it's pretty much the most basic load balancing algorithm that there is. And round robin just means first one first, second one second, third one third, and then repeat. And if you do that, then there should be an even distribution. So I think it must be B. I'm 90% sure that it's B. Indeed, round robin is a straightforward load balancing algorithm that distributes requests evenly across servers in a cyclic manner. This is what I was talking about. Ensuring balanced resource usage. Cyclic, I don't know how you pronounce it, but I'm going to call it cyclic. That's what I meant. Question 6. In the context of SRE, what does the term blameless postmortem refer to? A meeting to assign blame for incidents. A review process that focuses on identifying failures without assigning blame. A method for improving team productivity. A retrospective analysis of successful deployments. I mean, it's quite obvious here, even if you don't really know, you've never heard of the term before, but you can pretty much figure out that it's going to be B. A post-mortem is something you do after an incident. There is another word for it, because post-mortem, it sounds a little bit morbid. I forget what the other term is, but you do it after the incident. You don't do it in the middle of the incident. You do it after. So it is a review, and you're trying to identify the ultimate root cause, the ultimate reason for the failure, and don't assign blame, because it's not going to help you. So it's not you're not blaming people, and it's got nothing to do with improving productivity or looking back on successful deployments. It's the opposite of success. You're looking back on a failure. So it's definitely going to be B. And the answer is B. A blame is focused on learning from failures without assigning blame, promoting a culture of continuous improvement and accountability. Well, yeah, I suppose it's accountability as well, but without blaming. Question 7. Which SRE practice involves measuring the latency and error rates of requests to ensure reliability? So, okay, is it traffic shaping, capacity planning, performance monitoring, or incident response? So, you're looking at requests and measuring latency and error rates. So, for example, you would do this in distributed tracing, actually. The latency and error rates are two possible of the three most common stats. I forget what the third one is. So it's not capacity planning, B. It's not incident response, and it's not traffic shaping. It's performance. It's what they call performance monitoring. So for me, it's well, yeah. If you're measuring something, that's metrics, and that means monitoring. But actually, these particular metrics are discovered during the process of tracing, which is usually considered separate to monitoring, but under the same manner of observability. I do have a great video on observability that you can find in this channel, and I also have an observability exam as well that you can check out as well. But yeah, it's going to be it's arguable whether it's part of monitoring or not, but the answer to this is monitoring. We are talking about measuring metrics, so it's going to be monitoring. It's going to be C. Let's have a look. Indeed it is. Performance monitoring measures latency and error rates, ensuring that services meet their reliability targets and identifying areas for improvement. Question 8. What is the primary goal of capacity planning in SRE? Minimize the cost of infrastructure, ensure services can handle expected traffic loads, optimize code performance, enhance user experience. Okay, so I know roughly what capacity planning is in general. It's about making sure that it's like if you have a house and you're having multiple children over the years, you need a big enough house, right? It's having something big enough to cope with expected increase in workloads, let's say. So it's going to be B. Ensure that services can handle expected traffic loads. This implies that they might increase or that they may even surge, perhaps. So that's also part of capacity planning. You need to also handle not just average long-term growth, but also surges as well. So it's going to be B. It's nothing to do with code performance. It's nothing to do with UX. And if you do capacity planning properly, it probably will minimize your infra cost. But that's not the primary goal. That's a secondary win, if you like. The primary goal is ensure that you can handle the traffic load, which basically affects your ultimate workload. So it's going to be B. Let's have a look. Indeed, it's B. Capacity planning ensures services can handle expected traffic loads. Indeed, the demand basically, and that the more demand you have, the more you need to back it up in terms of compute and memory and disk and all that kind of stuff, network traffic. So capacity planning ensures that services can handle expected traffic loads, preventing performance degradation and outages during peak usage. Indeed. Question 9. Which of the following is a key advantage of using container orchestration platforms like Kubernetes in SRE? They eliminate the need for high availability, HA. They simplify monitoring and logging. They provide automated scaling and management of containerized apps, and they restrict the use of microservices. Okay, so if you don't know, by the way, like Kubernetes is the leading, most popular container orchestration platform. There are others that aren't as advanced, and before there were orchestration platforms, people were really just running regular Docker, really, and there was it's hard to describe what orchestration is, but you really couldn't do much. So let's have a look at the answers. Eliminate the need for HA. That's not true. Simplify monitoring and logging. Well, not necessarily. Actually, it's not a simple undertaking. Once you're on Kubernetes, you really need adequate observability as well, and that's no easy thing, really. They restrict the use of microservices. Well, that's not true. They provide automated scaling and management of containerized apps. I think that's more or less it. I would personally say that there are other ways to describe the advantages of container orchestration. Is the scaling automated? I mean, it can be. Not necessarily. And yeah, it's easy to manage the apps, but that's only real. Yeah, I suppose so. You get a new abstraction, the pod, and you get other resources which are other abstractions as well, and allows you to manage containerized apps. But you can manage them even without all that, just on a much smaller scale. So I would say that they help you do things at scale. It's probably the way I would describe it, and that if you're at very small scale, you don't need Kubernetes. So that's my argument. That's one argument. And to see exactly, container orchestration platforms like Kubernetes automate the scaling and management of containerized apps, facilitating operational efficiency and reliability. That I don't know what that. Those are just a load of buzzwords. I mean, they're true, but it's a bit of a buzzword bingo, C-level type answer, something that was learned at a conference. So ignore that part. If you came out with that line in an interview, people would look at you like like you're just full of it. So don't say that in an interview. Question 10. What is the purpose of implementing service meshes in microservice architectures? To provide a user interface for service interactions, to manage service-to-service communication and security, to serve as a data storage solution, or to replace traditional load balancers. So I think you've either got to know this or not. Maybe you get a clue, the fact that it says service, and maybe the fact that you can imagine what a mesh is, right? Physically, what a mesh looks like. It kind of looks like a chain link fence, right? So there are a lot of routes, let's say. I hope that gives you a clue. If you didn't know, then therefore it's going to be to manage service-to-service communication and security. It's service-to-service comms, basically. Nothing to do with the UI related to services. It's not data storage. It's not anything to do with load balancers. So it's got to be B. Let's have a look. Service meshes, indeed, is B. Service meshes manage service-to-service communication, enhancing observability, security, and reliability in microservice architectures. That is true, and I believe, if I remember correctly, that the way they operate is that they are a sidecar inside every pod alongside the primary container. And so, yeah, that's how you can especially get these cool features. So, yeah. So I hope so far you're still with me. You're enjoying this. If you do, please give it a like. And yeah, pretty challenging. Even though I haven't really read the Google SRE book properly, but I think a lot of this is kind of almost what you'd say is common sense. But it's kind of cool that they formalize this in a book. I like it. Question 11: in SRE, what does fidelity refer to when discussing monitoring practices? Accuracy of service level metrics, level of detail in monitoring data, reliability of monitoring tools, speed of incident response. I don't know. I mean, we know what fidelity kind of means. You've heard of hi-fi, high fidelity, with respect to audio. So I've got an idea, but I don't want to really push this idea hard in case it reinforces it too hard in my brain and your brain. And I want to easily forget it if I'm wrong. So let's have a look. Okay, I did think it was this. Fidelity refers to the level of detail in monitoring data, which is crucial for diagnosing issues and understanding system behavior comprehensively. Ignore all this word salad about crucial for diagnosing blah blah blah. The main thing is it's about the level of detail in your monitoring. If it's a high level of detail, then you've got a high fidelity. And that makes sense when you think about what fidelity, the dictionary word, means. Question 12. What role does observability play in SRE? Now, I just mentioned observability, so you should remember this if you didn't already. It allows teams to predict future system failures. It provides insights into the internal states of a system through external outputs. It measures user satisfaction with the service. It simplifies the coding process for developers. Okay. So, it's not coding process, and it's not about predicting future system failures, really. I'll come back to B. I initially overlooked it, but I think that's the right answer. It measures user satisfaction with a service. No, that would be a survey or something similar. It provides insights into the internal states of a system through external outputs. I thought this was word salad at first, or I thought it actually meant something else. Maybe it was a definition of something else that was just thrown in here to confuse. But actually, this is observability. You're getting insights. That's a key word there, insights. And through external outputs, through what you're measuring, and through your logs, and through distributed traces, that you're learning about the internal state of the system. So it's actually B. Let's have a look. I've never heard it expressed like that. It's a very interesting way to express it. Accurate. Indeed, observability provides insights into a system's internal states through external outputs, enabling effective monitoring, troubleshooting, and performance tuning. Yeah, indeed, performance tuning. So yeah, you can definitely make improvements, or not just improvements, but get more out of what you have as well. That's more to the point. Question 13. Which of the following describes toil in the context of SRE? Manual repetitive tasks that are automatable and do not provide long-term value. High-level strategic planning activities. Time spent on learning new tech. Activities aimed at improving system performance. Okay, so this is one of the early definitions in the SRE book. It's quite a fundamental principle of SRE. So it's not activities at improving system performance. It's not high-level strategic planning. And it's not time spent on learning new tech. I think that's got another name. Pretty sure it's this manual repetitive tasks that are automatable and do not provide long-term value. So the idea is that if you automate it, it might cost you some time to do it, but that should be outweighed by the time saving overall. And you don't even have to do a value comparison because you know you'll save time, and you won't have lost any. You won't have lost any value. There's no opportunity cost because they don't provide any long-term value. So it's got to be A. Indeed it is. Toil refers to manual repetitive tasks that can be automated, detracting from the time SREs can spend on engineering and improving systems. So here it doesn't say that that these tasks have no value. I actually need to check the definition of toil, because I'm not sure that manual repetitive tasks, although you can automate them, that doesn't mean that when they were manual and repetitive that they provided no value. I think that the original definition was wrong. I think that they obviously provide value, or you just wouldn't do them in the first place, right? You have to do them. They must provide some value. So yeah, I'm going to double check that definition of toil. Question 14. What is the significance of SLOs in SRE? They are used to determine the budget for infrastructure. They define the target reliability levels for services. They are metrics for user engagement. They serve as a guideline for coding standards. So remember, we looked at this earlier, right? We had SLIs and SLOs, and SLIs were the actual measured performance, and then you compare them to SLOs, which were the goals, the objectives. So these are goals. So it's got to be B, the target reliability levels for services, I think. It's not metrics or user engagements. It's not a guideline for coding, and I don't think it's used to determine infrastructure budget. It's not even error budget. This is just money. It's got to be B. Let's have a look. SLOs. Indeed, they define the target reliability levels for services, guiding the teams on acceptable performance and availability standards essential for operational success. Yeah, that's a bit of word salad. I mean, they're goals at the end of the day, right? They're reliability targets. They're goals. That's what they are. Question 15. What does canary deployment mean in the context of continuous delivery? So, you know, if you're into your DevOps, you should know this. Deploying an app to all users at once. A method to gradually release changes to a small subset of users to monitor for issues. A technique for rolling back a deployment. Or a way to automate testing in production environments. So yeah, you either know this or you don't, and I'm pretty sure that it's this one, a method to gradually release changes to a small subset of users to monitor for issues. It's like carrying the canary down the coal mine. The canary will, if it gets sick, everyone runs out of the coal mine. and that's the idea, that you're sacrificing this small canary, which I mean, it's not the best word to use, but it is common to use this phrase, canary deployment. The thing is, this small subset of users, I'm pretty sure that you're going to choose regular ordinary users. You might even randomly select them, and because they're going to be representative of the greater population of all your users. Whereas in a real life canary in the coal mine, this canary is kind of weak because it's small, right? And it can quite possibly die from the toxic gases, and everybody runs out, and you know, all the users aren't the same. The canary is kind of, unfortunately, it's a sacrifice. So anyway, I'm pretty sure it's B, indeed. Canary deployment involves gradually releasing changes to a small subset of users, allowing teams to monitor for issues before a full rollout, indeed. Question 16. In SRE, what is the golden signals concept primarily concerned with? Metrics that indicate financial performance of a service, key performance indicators, KPIs that reflect user satisfaction, 4 critical aspects of service performance: latency, traffic, errors, and saturation, the best practices for code deployment. Okay. Yeah, this is just a definition that you're just going to have to know or you don't know. I actually have a video on this, by the way. You can search for golden signals. I made that a long time ago, actually. And yeah, you either know this or you don't. I mean, if you didn't know, perhaps you can guess from the fact, the word signals, you know, that yeah, I don't know, but you still might choose the wrong thing. It's this one: 4 critical aspects of service performance: latency, traffic, errors, and saturation. So let's have a look. Indeed, 4 critical aspects of performance, those 4, and then some word salad. But I do recommend reading the SRE book, and in particular, I mean, if you do nothing else right after this video, go to AI and just Google what are the 4 golden signals of SRE, and just read what it says, because they're super interesting, and it's really nice the way Google have summed them up. Question 17. Which of the following best describes distributed tracing in observability? A method for tracking user behavior across platforms, a technique for monitoring app performance through request paths, a tool for logging system errors, a strategy for load balancing requests. So I think either you know this or you don't. Observability is monitoring, logging, and tracing, and alerts as well, but some people consider that part of monitoring. And what is tracing? It is following the path of the request and taking various measurements as you go along, and hopefully you're going to identify the bottlenecks, where they are, and then be able to fix them after, because you've been able to look to use the magnifying glass and zoom in. So it's not user behavior, it's nothing to do with their behavior. I mean, it all starts with the user behavior, but you're really more interested in what happens after that as the request goes through your system. It's nothing to do with logging errors or load balancing. So it's got to be the one I thought, which is B. Tracking request paths across services, helping identify bottlenecks. Didn't I just say that? And performance issues. Indeed. Question 18. In SRE, what is the purpose of incident management? Wow, man, I'd be amazed if anyone gets this wrong. To reduce the number of services in production. To improve the user interface of apps. To handle outages and service disruptions effectively. And to allocate budget for new projects. Come on, everybody knows what incident management is. I hope you do. If you don't, then it's worth having a look, particularly at ITIL. And particularly, I bet you a lot of people watching this video do not necessarily know the difference between incident and problem management. And I do recommend that you just go to AI and say incident management versus problem management, and have a good read, because that is a little bit more interesting than this question. Let's have a look at the answer. Indeed, it's C. Handling outages and service disruptions effectively, ensuring quick recovery and minimizing impact on users. Question 19. What is the main benefit of using automated testing in the SRE workflow? Eliminates the need for manual reviews, speeds up deployment process while ensuring quality, allows for more frequent user feedback, increases the complexity of the code base. Well, okay, D is not a benefit. So I'm familiar with automated testing, and that there is a drive to shift left, to do as much testing early in the process and to automate as much of it as possible, rather than the old school way of leaving testing to a dedicated QA team right at the end of the process. It's just the first way I mentioned is the more modern way. It's quicker, it's better all round. So automated testing is part of that. But I noticed as we read through these that some of them do apply kind of for all of them. So the main benefit is not D, but however A, B, and C do kind of apply, right? So I wouldn't say it eliminates the need for manual reviews, but you would probably have fewer manual reviews. You would feel that you wouldn't need as many. You still need some, so it doesn't eliminate, it reduces. So I'm going to scrub that out because I don't think that's the main benefit. Speeds up deployment process while ensuring quality. Indeed it does, right? If you shift left, if you do more automation, you should have high quality and be able to deploy faster. You won't get so many, I don't know if this is the correct word, but you won't get so many kickbacks in the process. You won't have to go back to basics, back to the beginning and rewrite your code or anything. It allows for more frequent user feedback. It does actually. If the life cycle has a higher velocity, you can more quickly push out the features, then you can get more frequent user feedback because you'll be interacting with the user more often. But I don't know if that's the main benefit of automated testing. I think it's got to be B because it mentions the quality, which is key, and it speeds up deploy. I think it's got to be B. I hope that's the answer to this question. If not, I'm willing to have a debate on that. Indeed, automated testing speeds up deployment process while ensuring quality, allowing teams to release changes confidently and frequently. Yeah, confident. You can be confident. It's automated, and you can still be confident about it, even though it might not have eyes on it. And frequently, more frequently, faster, increased velocity. So definitely. And we made it to question 20. I hope you're still with me. I've really enjoyed this. Which of the following best describes the concept of site reliability in SRE? The process of ensuring a site is aesthetically pleasing. Obviously it's not that. The practice of balancing development velocity with operational stability. The use of load balancers to manage traffic. The measurement of server uptime only. Okay, so C is way too specific. It's not that. It's not A. Obviously, I laughed at that. Come on, everybody knows that. The measurement of server uptime only. You know, I could understand that 20 years ago maybe there could be a framework that just said uptime is the only thing that matters, but not today. It's not D. It's got to be B, and B is what I was talking about before. Well, I was talking about that partially with automated testing, but I actually like the way this is summed up. I didn't realize this was written in the SRE book, that there's a trade-off between development velocity and operational stability. And you can't necessarily have bleeding edge velocity and being able to get features out like there's no tomorrow. If you do that, your stability is going to suffer. So it's a trade-off, it's a balance. So I do like that summed up, and it's very rare that I've ever heard anyone in the workplace mention that. And that is really cool, actually, because a lot of people in DevOps forget that, right? DevOps is considered to be all about speeding up the software development lifecycle, increasing velocity. But I've always said it's also about having site reliability. But I never hear other people talk about that. They always ignore that. They just say it's automation to increase developer velocity. And I come from a sysadmin background, and I've always had site reliability very, for most of my career, first and foremost. So I like the fact in SRE they say, look, there is a balance, it is a trade-off, you can't have both. Don't focus on one at the exclusivity of the other. It's a balance. So I really like that. I think that is actually awesome. I might make a future video on that, note to self. So that is question 20. Well, let's just see if I got the right answer here. I've assumed it. It's got to be. There we go. Site reliability is balancing velocity with stability, ensuring services are reliable but still allowing rapid feature delivery. Isn't that what I just said already, pretty much? So there we go. That was 20 SRE questions. I don't know how you did. I don't know how you felt about it. I really, really enjoyed that. I'd definitely do a similar test again. I really thoroughly enjoyed that. If you did as well, please give this video a like. I have other questions as well. not only SRE, I have networking and other different things as well. You can go check them out, because you never know in a job description, no matter what the job title, they might ask or be looking for certain specifics in certain areas, and a test like this can help you make sure you don't have any blind spots and see if you're interview ready or test ready. So I really hope you enjoyed this. Please check out my other videos, give this a like if you enjoyed it. I will see you again soon. Take care. Bye bye.